Welcome. So in a Chem 101 Intro Chem class, most reactions covered will fall into one of these 5 reaction classes. We have first combination, where 2 things will combine to become one product. Decomposition is going to be one thing decomposing into 2 or more things. The decomposition examples typically covered in 101 will be like the exact opposite of a combination. They'll often involve the input of energy, such as heat, which is shown in a triangle symbol, capital Greek letter delta, or maybe like electrolysis if you're splitting water into hydrogen and oxygen molecules. Single displacement, we're going to have something getting displaced. We're going to have some sort of compound, like a BC compound, just a single compound, and one element, usually an ion, is going to be displaced by some new element. So A takes the place of B, and then B gets kicked out. Double displacement is going to involve 2 compounds experiencing a swap of ions. Lastly, we have combustion. You need some type of fuel, but the main thing you look for is the O2 as a reactant to consume the fuel. So O2 somewhere on the reaction side. So my experience teaching 101 is almost all the reactions we cover will fall into one of these 5 reaction classes. Now there's these other reaction type labels that apply to many of the reactions as well. So I made this flow chart here to see when these other labels apply. Now you can see that combination, decomposition, single displacement, and combustion all point at redox. What is redox? Redox is short for oxidation-reduction. Ox, red, redox, flows off the tongue perhaps a little better. Redox means electron transfer. We move electrons from one substance to another within the chemistry system so that you can make bonds or break bonds. Think about it, for example, you have a metal and a non-metal. Metal gives electrons to the non-metal. You have positive, you have negative, and now they can make an ionic bond. So that's maybe driving some of the processes with these first 3 in the last reaction class. But now we have double displacement. Double displacement is not redox. We already have ions, and we're just exploring new bonding possibilities, no movement of electrons. When it comes to double displacement, you're going to have either a precipitation possibility or an acid-base possibility. Precipitation reactions are when you have aqueous ions floating around in your solution, but once they collide with each other, if you were to make a solid, that solid stays. It's irreversible. That solid is marked with an S, not with some other phase label. S stands for solid. I know S, some people think it stands for soluble, but S is for solid. And it's kind of like the weather. When you're studying the rain, the snow, you think of precipitation, like appearing out of nowhere, right? Similar thing here. You have your reaction vessel, and that precipitate appears out of nowhere once you mixed your 2 things together. So that's precipitation. You look for it to get cloudy if you're doing a reaction in the lab. Whereas an acid-base reaction, you're going to have an acid, a base. Acid is going to be an H+ source typically, and then base is typically going to be a hydroxide source. And so H+ plus OH-, you make liquid water. Acid-base reactions, you may not always see evidence of it with your eyes when you mix things together, but especially at higher concentrations, you will feel these get quite warm because making water is an exothermic, heat-releasing process. Water is a very stable molecule. Lastly, we have gas formation. Gas formation reactions, I don't have a bunch of arrows pointing at it because any of these 5 could be a gas formation reaction. You just look for gas on the product side, and if you're in the lab, you would just see bubbles being made, and that's how you know you made a gas. All right, so the next videos I have planned is to go into these more specifically with example reactions of predicting products and balancing the equation for each of these. All right, hope this helps, and let me know if you have any questions. Thanks and take care.